Hello everyone, welcome to the session on support vector machines. I am Prasanna. Before we deep dive into the support vector machines concept, let's look into the decision boundary definition. So what is a decision boundary? It is a boundary which decides the classifications. So the classifications like for example in this case car reviews of type car C1 and car other car reviews are CO. You can see whatever car reviews present inside the circle are denoted as C1, which is car type C1 review, and whatever which is outside is CO, other car reviews. So let's now look in, this is a circular shape. Let's now look into an irregular shape like this, what you see below. You have the training data represented in blue, and in this inside this irregular shape you have the blue positives. Those are the positive customer reviews, and of course you have two negative customer reviews which you can ignore. And you can see the other the negative training data blue are present outside to the right. And you can see the test data represented in the black. You can see majority of the test data positive customer reviews are present outside the shape. Therefore, it does not fit into this model exactly. The data does not fit into this. So this is defined as data overfitting, as the test data are present outside of the test of this shape, positive and negative. Of course, negative satisfies, but the positives are outside. And this decision boundary is trained with this training data, and it does not help to generalize the test data. Therefore, this is called as data overfitting. So we looked into the decision boundary, and we looked into one of the disadvantages of having such kind of a shape. So instead of having a shape, why not we use a linear plane in this case? So linear boundary instead of irregular shape in order to avoid this data overfitting problem. You can see here the positive customer reviews for the car are present to the left, and to the right the negatives. So you can see the training and test data fit exactly here as compared to the previous diagram. So as it is a linear plane, it is easy to divide such two classes of data. And further moving inside this plane, you can see here now we have drawn two additional planes, one to the top and one to the left. And you can see on the top plane, the positive customer review point data points are overlapping, as well as in the below plane, you can see the negative customer reviews are overlapping. So you can say there is this is the bandwidth, yeah, this is the margin. So in the middle plane, we can call that as the hyperplane, maximum margin hyperplane. And these are nothing but the support vector machines. So you can say support vector machines are linear classifiers which that determines the hyperplane in the middle, that divides the classes, two classes of data, positive and negative. For example, in this case, customer car reviews. Yeah. So let's say, for example, of course, the training data. So just to say, we have to have the customer reviews. So it would be in words, and output would be either positive or negative. Let's have it as numerical output as minus +1 and -1. So you can see here, this is how the training data is, and the test data would, of course, follow the same order, and we have to find out if that matches what the support vector machines gives out. So let's look into the types involved in this support vector machines. So multi-class classification. So it will have more than two classes, of course, as we see before as well. So C1, C2, C3 are represented like this, three different car reviews. And you can see here, we are dividing the car reviews by a plane. Here, and then here, and then here. So one versus one. So for example, this plane separates the car review C1 from the other two car reviews. Similarly, you can see the other planes. So this one separates out the other two car reviews. So we are taking one car review type against the other. So when we take C1, it is against C2 and C3. When we take C2, when we take C1, it is, sorry, 1 versus 1, it is like C1 versus C3. So C1 against C3, and then if it is C2 against C3, and then C2 against C1. So it is not considered together. So this is one type of classification. So other one is one versus rest. You can see here, in this case, C1 against both the other car reviews, C3 against both and C2 against both. So this is one versus rest. So one versus rest has less number of classifiers because it doesn't have to do separately each of the other classes, and therefore cannot handle multiple data set. You can say it is a faster approach, and therefore it is preferred over the other one versus one. So repeat, one versus one, this is only between two classes, but here it's between one class against the other two classes. So finally we come to some SVM parameters. For example, let's take regularization. It is denoted as C. It is the measure of the importance of the data points which are present in the model. Say we have here different data points, and these data points have some importance. So that is that is measured with as regularization C. So it is inversely proportional to the tolerance. That is, more the regularization, if the regularization is larger, then every data point is important. So the training data must be fitted properly. So there is very less tolerance to errors in the data points. But if it is small, then of course the data points are not important, and therefore we can have more tolerance. So it is inversely proportional to the tolerance. Yeah. Here we come to the end of the session. Thanks for listening.